Hello everyone, welcome to our podcast, a special episode as the part of our electrical and electronic engineering life skill subject. Today we dive into one of the Kerala's most significant engineering marvel, the Idukki hydroelectric power project. To start, I did you like to introducing myself. I am Suraj V. Suresh and welcome all of our listeners to this episode on the Idukki hydroelectric power project. Our team of 10 members will take you through the various aspects of this remarkable project. We begin with its background and history, exploring how the vision for the Idukki took its shape. Then we move to the technical aspects, discussing the dam's construction, power generation process, and the engineering innovations. Next, we analyze the economic impact, understanding its role in Kerala's development, followed by a took at its social impact, including the effect of the local communities, and we also addressing the environmental impact, discussing both benefits and concerns related to the sustainabilities. Finally, we exploring the future prospects and challenges, including modernization and energy demands, before wrapping up its comprehensive conclusion. Join us as we unreveal the story of Idukki hydroelectric power projects and its engineering brilliance and its impact on social and environmental. Let's get started. First of all, to understand the origin of this project, let's dive into its background and history. How did the idea of the Idukki Dam take shape, and we were the challenges during its construction, and to take us through its journey. We have to speak about this as our members Srinandana KM and Shreya K. Over to you guys.
Hi everyone, I'm Shreya K and I'm here to talk about the history of Idukki's hydroelectric dam. The history of Idukki Dam dates back to an era when mechanized construction systems were not yet in existence. It was just a vision shared by a group of engineers and the hard work of thousands of laborers that transformed this project into a marvel of construction. The idea of constructing a dam for power generation was initially conceived in 1919 in a report by Italian engineer Jacob, which was unfortunately rejected. It wasn't until 1922 when Sri Chempan Kuruvalan Kolumban, the leader of Urali tribe, guided W.J. John and A.C. Thomas Idatu, who were on a hunting trip to the present Ark Dam area. Impressed by the Kuruvan and Kuruthi hills, they recognized this potential for an Ark Dam at that site. In 1932, W.J. John submitted a report to the government of Travancore regarding the feasibility of constructing a dam at Idukki for power generation. The idea gained momentum when Assembly member Sri K. N. Narayanan Pillai raised the Idukki project's profile in 1935. Italian engineers Angelo Amadeo and Clementia Messele conducted a study in 1937, but progress remained slow. It wasn't until 1947 that a preliminary investigation report was submitted by Sri P. Joseph John, the chief electrical engineer, to the government of Travancore. The Central Water Commission conducted a detailed investigation in 1956 and the project report was prepared in 1961. The construction of Idukki Dam commenced on April 30, 1969 under the leadership of Dr. D. Babu Paul, IAS, who was appointed as the project coordinator. With the support from the Canadian government in the form of loans and grants, the project saw assistance from SNC Lavalin, a renowned Canadian firm of consulting engineers, along with the construction by the Hindustan Construction Company.
Hi friends, I'm Srinandana KM. I'm gonna disclose about the background features of Kerala's largest Idukki hydroelectric project. First of all, it is situated in the picturesque state of Kerala. The Idukki Dam stands as a towering testament to human engineering and innovation. Its recognitions are it ranked as one of the Asia's tallest arc dams and is globally recognized as one of the 22nd tallest arc dams worldwide, taking the third spot in India's list of highest dams. Coming to the detailing of Idukki Dam, it is a double curvature concrete arch dam, stretches 555 feet high, ingeniously connecting the 839-meter high Kuravanmala and the 925-meter high Kurathimala. The architectural wonder is complemented by the two other dams at Cheruthoni and Kulamavu. Together, these dams, along with the two saddle dams, have created a vast artificial lake spanning 60 square kilometers. The stored water from these lakes serve as the source of power generation at the underground power station. Strategically located 750 meters below the Nadukani Hills in Mulamattam, the power station operates through penstocks and the tail race water. After electricity generation flows into the Kudayattur River via a tunnel and an open channel. And coming to its geographical background, the Periyar River, originating from the Shivagiri hills of the Western Ghats in the southeast of Idukki, gracefully cut across the district, meandering in a northwesterly direction towards Ernakulam district. A pivotal point in the river's journey is the confluence of Periyar and Mulla rivers, where the Mullaperiyar Dam stands tall, creating the Periyar Tekadi Lake and Reservoir. Intriguingly, some of the water from the Periyar Tekadi Lake and Reservoir is diverted eastward to Tamil Nadu. After generating power, it flows into the Surulia River, leading to an inter-basin transfer of water. Downstream of the Mullaperiyar Dam, the Periyar continues its northwestward journey, passing through Vandi Periyar, Ilappara, and Ayyappankoil before reaching the Idukki Reservoir. This reservoir is formed by trio of dams, Idukki, Cheruthoni, and Kulamavu, built across the Periyar River in the famous Idukki Gorge nested between the Kuravan and Kurati hills. Further downstream, the Periyar River flows northward in parallel to the western edge of the Idukki Plateau. Along the way, it joins forces with its major tributaries such as Perinyangutti, Iramalayar, and Mudirapuzha, shaping its course as it enters Ernakulam district at Neriyamangalam. This dynamic river eventually joins the Bhudathankede barrage. So, its rich history and geographical significance also created a jewel in Kerala's crown. And that's about my topic. Thank you guys for listening.
Okay, the Idukki Hydroelectric Project is an engineering marvel, featuring India's first arc dam as an impressive underground power station. To explain its technical aspects, including design, power generation, and operational efficiency, we have Siddharth MS and Sneha K. Let's hear their insights.
Hello everyone, I am Siddharth Thamas. Today I am going to discuss about the technical aspect of Idukki Hydroelectrical Project, which is one of the largest projects in India. It is located in Kerala. Its key techniques are power generation system, installed capacities and turbine. Initially, it has a capacity of 319 megawatts, which is later upgraded to 718 megawatts, and it has 6 units. It has a vertical axis Francis turbine. Each unit has a capacity of 113 megawatt. It has 3 penstock system. Its function is to transport water from the reservoir to underground powerhouses. The powerhouses and the transmission, which is located at Moolamata, and it has 6 generators. Each of them have a capacity of 113 megawatts. Generator voltage is approximately 15.75 kilowatt. The step-up transformer output is 220 kilowatts. The technical aspect of Idukki hydroelectrical project is discussed by Sneha K.
Okay, so I am Sneha and I am here to present the remaining parts of the technical aspects of Idukki hydroelectric project. So my topic is auxiliary systems and safety features. So the spillway gates, which is located at Cheruthoni Dam, is 5 radial gates, and the sediment control is managed through periodic flushing, and the flood control is managed through Cheruthoni Dam, which regulates excess water, and the seismic design is built to withstand earthquakes in the Western Ghats region. And the next topic is operation and efficiency. Annual energy generation is approximately 2000 to 2400 million units, and the load factor is 40 to 50%, which varies with the monsoon. And the pump storage facility is not available here. And the last topic is the water flow and operation. Water from the Idukki reservoir flows through 4.32 km long tunnels to the Moolammattam underground powerhouse. The turbines operate under a net head of 218.4 meters. The electricity is transmitted via 220 kilovolt and 4000 kilovolt transmission lines. So that's it. Thank you.
The large infrastructure projects affects people's lives in many ways. From resettlement to employment opportunities, the Idukki Power Project has had a profound social impacts. Here to discuss this in details is Suraj KM. Let's hear from them.
Hello everyone, I am Suraj KM. I am really excited to talk about something that has changed the lives of many people in Kerala. The Idukki hydroelectric project. This dam is one of the biggest in India and it has helped us in many ways. But like everything, it also has its downsides. So let's dive into the social impact of the Idukki Dam. First, let us talk about the good side. The biggest benefit, electricity. Before this dam was built, Kerala had power shortages, but after it started working, we got a steady supply of electricity. Factories, homes, and business started running smoothly. It gave a big push to development. Another good thing is that it created jobs. During construction, thousands of workers got employment. Even after that, many people got jobs in maintaining and running the power plant. The roads and transport in the area also improved, making life easier for people living nearby. And let's not forget tourism. Many visitors come to see the dam, helping local business grow. But there is also other side of the story, the struggles of the people who lived there before the dam was built. Many families, especially tribal communities, were forced to leave their homes. Their villages got submerged underwater, and they had to start from scratch somewhere else. Some of them never got proper compensation or support. Imagine losing the land where your family has lived for generations. That's what happened to many. The environment also took a hit. Huge forests were cleared to build the dam, affecting wildlife animals, especially elephants, lost their usual paths, leading to more conflict between humans and animals. People in the area have seen more wild animals coming into their village because their natural habitat has changed. There is also another scary part, earthquakes. Some study says that huge amount of water in the dam put pressure on the land, which might be causing small earthquakes in the region. This makes people worried about what might happen in the future. So in the end, was the Idukki Dam a success or a mistake? Well, it's both. It gave us power and development, but it also caused problems for many people and the environment. The real lesson here, big project like this should not just focus on development, but also take care of the people and the nature around them. So, what do you think? Should we build more dams like this or should we find better ways? Let me know your thoughts. This was a great discussion. Thanks for listening.
Okay, Idukki hydroelectric project offers clean energy, but they also come with environmental challenges such as deforestation and ecosystem change. To discuss the environmental impact of the Idukki project, we have Suraj V and Surya Kiran. Over to you guys.
Hello, my name is Suraj and I'm gonna talk about the environmental impacts of the Idukki hydropower project. The creation of Idukki Reservoir formed by damming the Periyar River led to the submergence of vast tracts of forest land, displacing wildlife and disrupting ecosystems. The loss of biodiversity, including endemic species of flora and fauna, has been significant. Additionally, the alteration of natural river flows has impacted aquatic life downstream, affecting fish populations and the livelihoods of communities dependent on the riverine resources. Deforestation and land use changes have also contributed to soil erosion and increased the risk of landslides in the region, a concern that has grown more pressing with the changing climate. While the project has provided clean energy, reducing reliance on fossil fuels, the long-term ecological costs cannot be overlooked. Efforts to mitigate these impacts, such as afforestation programs and wildlife conservation initiatives, have been implemented, but critics argue that more needs to be done to balance development with environmental preservation. The Idukki hydropower project serves as a reminder of the delicate trade-offs between progress and sustainability, urging us to rethink how we harness natural resources for future generations.
I am Suryakiran of S2 B section. I am here to talk about the environmental aspects of the Idukki hydroelectric project. The environmental aspects of Idukki hydroelectric project includes habitat loss and biodiversity. Submerged areas. The construction of Idukki Dam and reservoir resulted in the submergence of extensive land areas, leading to the loss of valuable habitats for various plant and animal species. Endemic species. Many endemic plant and animal species adapted to the specific condition of the region have lost their habitats due to the reservoir, raising concerns about the conservation and ecological balance. Displacement of communities. The submergence of land also led to the displacement of local communities. who were dependent on the natural resources of the area for their livelihoods. The impact on river ecosystems, sediment deprivation, dam trap sedimentations, leading to the reduction in natural flow of nutrient-rich sediments downstream. Erosion and reduced fertility. The lack of sediment downstream can cause erosion of riverbeds and banks and reduce the fertility of agricultural land along floodplains. Impact on fish population. Dams can disrupt the natural migratory paths of fish, leading to a decline in fish populations. Other environmental concerns include construction phase impacts, solid waste, water quality, seismic activity, and catchment area treatment. Thank you.
What lies ahead from the Idukki hydroelectric project? With evolving technology and increasing power demand, modernization and sustainability are the key concerns. To explore the future perspectives and challenges, we have Sona S. Let's hear their thoughts.
Hello everyone, I'm Sona S. I'm gonna talk about the future prospects and challenges of Idukki hydroelectric project. Now let's first discuss about the future prospects of Idukki hydroelectric project. First one is increased power demand. With Kerala's growing electricity needs due to urbanization and industry expansion, the Idukki project remains a key energy source. Potential upgrades in power transmission infrastructure can improve efficiency. Second one is integration with renewable energy. The project can complement Kerala's push for solar and wind energy, balancing grid fluctuations. Pumped storage systems may enhance efficiency by storing excess renewable energy. Third one is technological advancements. Smart grid integration and automation in dam operation can optimize energy production. Advanced turbine efficiency improvements could increase output with the same water volume. Fourth one is ecotourism and conservation initiatives. The scenic location and wildlife sanctuary near the reservoir can boost ecotourism. Sustainable practices may create employment and economic growth. Now let's discuss about the challenges of Idukki hydroelectric project. In challenges, the first one is environmental concerns, deforestation, soil erosion, and loss of biodiversity due to reservoirs impact on the Periyar River ecosystem. Sedimentation and water quality issues affecting aquatic life is affecting it. Second one is climate change impact. Unpredictable rainfall patterns and droughts can reduce water availability. Extreme weather events may threaten dam safety. Third one is aging infrastructure and maintenance. The project commissioned in 1975 faces wear and tear, requiring regular maintenance and upgrades. Risk of dam failure or leaks due to structural aging is also facing it. Fourth one is seismic and geological risk. The region is in a seismically active zone, raising concerns about earthquake-induced damages. Landslides in the Western Ghats pose a risk to infrastructure. And the last one in challenges is social and political challenges. Local displacement issues and conflicts over water usage between Tamil Nadu and Kerala. Bureaucratic delays in implementing modernization projects is also there. While the Idukki hydroelectric project will continue to be a vital part of Kerala's power sector, it must adapt to climate change, environmental concerns, and technological advancements. Sustainable practices, modernization, and better water management will be essential for its long term success. Thank you for listening.
Okay, now the time to summarize our discussion and highlight the key takeaways. We have Sritu VV presenting the conclusion of our podcast. Over to you.
As we conclude our discussion on the Idukki hydroelectric project, it is clear that this engineering marvel is not just about power generation. It is a testament to human innovation and Kerala's commitment to sustainable development. The Idukki Dam, with its impressive structure and massive reservoirs, plays a crucial role in meeting the state's electricity demands, supporting industries, and ensuring a stable power supply for millions. Beyond energy production, the project has also contributed to irrigation, tourism, and environmental conservation, making it a multifaceted asset to Kerala. However, with increasing concerns about climate change and water resource management, the future of hydroelectric projects like Idukki depends on balancing development with sustainability. As technology advances, the integrating modern solutions like smart grids and improved water management strategies can further enhance its efficiency. The Idukki project serves as an inspiration, reminding us of the potential of renewable energy in shaping a greener and self sufficient future. That brings us to the end of today's episode. I hope you found this journey into the world of hydroelectric project insightful. Stay tuned for more interesting discussion. Until next time, this is Ritu Vivi signing off. Thank you for listening.